Okay. So either way, last session we were doing some practice problems on chapter 9. Remember that this file is not posted, so you guys are gonna have to be very aware to what's on the screen. Excuse me? It's gonna be posted after we're done with it. Yes. But we were done with a spectrum question, which was this one, right? Okay. We were feeling pretty okay with it. We saw just characteristic peaks. That's how we figured out the the molecule. But any questions on the last problem we were talking about on Monday?
Yes, can you go
Over it again?
Yeah.
Okay. Let me see. Okay. So let's, yeah. Okay, so first of all, whenever you're given a spectrum, first of all, I would just start by rating the number of signals. Sometimes you're not gonna get the answer right away just by looking at the number of signals. But usually whenever you have something that's very deshielded, like something around 10 to 12, that's a very characteristic peak. What wasn't there? Around 10 to 12. Carbonyl groups, exactly. So just by knowing that, you can start discarding some answer choices. Specifically, I gave you the specific ranges for aldehydes, carboxylic acids, ketones, those guys. So since you have the more specific one, you can start discarding your aldehyde, okay? Now, next one is your signal that has an integration of 5H, and we see that it's around 7 to 8 ppm. Aromatic rings, exactly. Anything around 7 to 8, that's an aromatic ring. So we can start, again, just discarding B. That one is not an aromatic ring. It's a ring, but it doesn't have the double bonds required for it to be a double bond. Sorry, for it to be a benzene. And then the next glue that we used was just integration, which was 5H. We can discard some, whoops. We can discard some of the answer choices like D, because in this case, the benzene was just composed of 4 hydrogens, so it doesn't match with the data. And then also for E, to eliminate E, we notice that we have a methyl group, so that means that the integration should be 3H, which is something that we're not given in the spectrum, okay? So it's basically just rating characteristic things that you notice, okay? Okay, are we ready for the next problem? Okay, let's just go for it. This time you're given the data written out, not in the spectrum. Again, same type of question, just what's the molecule based on the information that you're given there? As soon as you get an answer, just raise your hand. Answer? Molecules here? Okay, I have one vote for B. What about the rest of you guys? Mhm. What do we think?
Two.
Two as well. Okay, I have two votes for B. B as well? Someone in the back. What do you guys think? Okay, so we all agree that it's gonna be option B. Okay, why is it B? What did you notice? What do you think it's B? Because it has four signals. Okay, that's one of them. What's another clue that you had? Exactly. So those two are very characteristic features of the molecule in here. So first of all, and oops, let's pretend that we didn't look at it. Either way. Okay, so in this case, we're just given four signals. So just by knowing that, you can start discarding some answer choices. Molecule one, how many signals do you see for H and R? Two. So it doesn't match, we discard it. Two, of course, is gonna have the four ones. What about molecule three? How many signals do you see? Five, four, molecule four. Five as well, so it doesn't match. And molecule five, four signals. Okay, so just by counting the number of signals, you had a 50-50 chance of getting the question. Now, next thing, we said that it was the septet that we saw in here, but do they both have septets? The little baby hydrogen in here, the only neighbors that it has are the ones in the meta group, which is 6. That does give me a septet. But on the other side, we have the hydrogens in the meta groups. What about the two hydrogens in here on the left side? Would they be neighbors? Yes, because remember, they have to be within 3 bonds away. 1 bond away, carbon. 2 bonds away, carbon. 3 bonds away, I touch the hydrogens. So it's more than just a septet. So that's why molecule 2 is the only one that corresponds to the data that we're given. Yes. Question?
Why would molecule one only have 2 signals?
Okay, so in molecule 1, we only have 2 signals because first of all, remember that all of the hydrogens in your benzene group, they're grouped together. So that's first signal. And then we don't have any hydrogens connected to this carbon. And then the rest of them, all of those are equivalent because of the single bond that keeps rotating. Mhm. Okay, questions on that? Was it easy? Was it hard? Confusing?
When you explain it now.
No, it makes more sense. Okay, ready for the next one? Question. The file is not posted yet. So yeah, you guys are gonna have access to it once we're done with the handout. Yes. For this one, when we just talked about that, yes. Okay, let's erase this so it's easier to see. But remember that we had a signal with a septet as a multiplicity. So usually that means that you're nearby an isopropyl group, which could be the hydrogen in here. But we do have neighbors, those hydrogens as the meta group. But remember, the rule is that they have to be within 3 bonds. So 1 bond away, I touch a carbon. 2 bonds away, I touch another carbon. 3 bonds away, I'm able to reach 2 extra hydrogens. So that's gonna give me a multiplicity higher than just a septet, okay? Okay, any other questions? Do we get it? We're good? Okay, ready for the next one? We're good? Again, read it carefully. Yes. I'm sorry, say that again? Rule number 5, because the signals didn't have a septet. Sorry, the molecule doesn't have a septet. None of the signals have a septet. But let's go back to this one. Again, read it carefully. Yeah. Same process as before. As soon as you get your answer, just raise your hand. Okay, that was fast. B, we think it's B? B, okay, we have B and D. Two different, yes. D as well? Okay, what do you think? You're good. Wrong class, but that's the spirit. Anyone else? Anyone in the back? We think it's B as well? Okay, so we're pretty even between B and D. Okay. If you chose option D, why did you choose option D? What did you notice?
It says assume you can separate CLCs.
Exactly. That's why I was telling you guys to read the question carefully. You're given a little disclaimer at the end of the question. So you have to be a little more careful whenever you have hydrogens in a benzene group. Okay, so let's just start looking at the data that they're giving us. So we have 5 HNMR signals and we have 7 CNMR signals. Okay. Now, how did you guys start solving this question? Did you look at HNMR, CNMR? HNMR. Okay, let's start looking at HNMR. So let's go molecule by molecule. In molecule 1, how many signals do you see? 3. So doesn't match. We discard it. Option B, how many do you see?
8, 9.
We have 1, 2, 3, 4. Don't forget about baby hydrogen. 5. These guys are 6. These 2 are 7. Okay. So we have a little too many hydrogen signals in there. So we discard B as well. Okay. Option 3, how many signals do you see? 5. So far it's matching up with the data. And then last one, of course, is gonna have 5 hydrogens. But for option 3, how many CNMR signals do you see?
It's almost similar. Except the little.
This one is 5 carbon signals. And then we have 1, 2, 3, 4, 5, 6, and 7 carbon signals. Okay. Remember that the only reason why I didn't group together my hydrogens in my benzene group is because of the disclaimer that I have. Okay, assume that you can see all of the signals.
Well,
So-
they didn't say that. You would group them together.
Then you're gonna group them together. Exactly. Okay.
Yeah, how?
Whenever you don't see the disclaimer, the highlighted part, if you don't see that, you group them together. Okay, so again, please read each question carefully. Okay,
So if it wasn't, if it didn't say that, it would be what, how many hydrogen? Would it be? Just
for HNMR, it would be
One.
1, 2, 3, 4. Okay. Okay, ready for the next one? I'm gonna give you 3 questions in one, because they should be pretty simple. Again, read the question carefully. Ready? We're good? He's gonna give you a disclaimer if you're gonna see them as separate or not. If you don't see any disclaimers, anything in parentheses, you group them together. Mm-hmm. Yes, he's gonna be very specific about that. Okay. Hopefully you guys remember this wording specifically. Yes. We think it's gonna be B, B, A, and what about the last question? A. B, B, A.
It just was your sandwich.
That sounds like a Star Wars character. I just noticed that. Okay. Any other guesses on that? What is the question asking you for? Multiplicity, okay. Specifically, they're saying which one shows spin splitting. That little phrase. What are we looking for? For something that has something higher than a singlet. Exactly. So for molecule, for the first molecule in question 3, in that case. Who can help me to draw out the molecules in bond line? All of them, actually, because it's better if you guys practice. Okay, you wanna do it? Go for it. Show me all of the molecules in bond line. Because right now it's given in condensed formula. Okay, we have a bromine, 2 carbons, and my dear bromine. Perfect, that's molecule 3. Molecule 4. And then we have, perfect. Now, for molecule 3, how many signals do you see? For molecule 3? For the first molecule that you just drew with the bromines.
Oh, sorry, I think the third one.
You're good.
One.
1, why 1?
Symmetry.
There's symmetry. So please draw the plane of symmetry right there. Beautiful. So what's the multiplicity for the one and only signal? Singlet. So it's not showing any splitting. Then same process for molecule 4. Next question. How many signals? 2. What are their multiplicities? Singlet. So am I showing splitting or not? Not. And what about the very last molecule? 3 signals. Do we have something higher than a singlet? What are the multiplicities that you see?
Doublet,
That's one of them.
septet, and
Septet
singlet.
and singlet. Beautiful. We have 2 signals with something higher than, beautiful, than a singlet. So it is showing splitting. Okay. Again, great job. Okay. Questions on that? And actually, if you notice, they are the same exact questions as we saw in SI. They're just given in condensed formula. Yes. It's no splitting, and then splitting, so BBA. It's splitting because we have signals with something higher than a singlet. Okay, any other questions on that? Again, the wording is a little weird, but the question itself is pretty simple.
Wait, it's a singlet because it has no neighbors from, right? But like, why is it?
For this guy in here, we have 2 signals and none of them have any neighbors adjacent to it. Okay, ready for the next one? We're getting into mass spec now. We're good? Okay. This one should be relatively easy. I hope so, at least. I just want the molecular ion peak.
Would be
42?
44.
44. You guys are absolutely correct. Okay. Usually your M plus peak, what are other names that I can call it? Peer and peak, or just your molecular ion peak? They're the same exact thing. Now, usually, where do I find it in a spectrum? Just to the right, any peak to the right? Tallest one to the right, exactly. What does it represent? Original weight, exactly. Yes. I saw that he gave you a little exception. In lecture, you saw a bunch of exceptions, okay? So I know it's really overwhelming, especially as a student, but I wouldn't worry too much about those. On the exam, he tends to be pretty clear on the examples. Plus, if anything, if there's something that's not really clear and that a lot of students get it wrong, he's gonna curve the exam. He's gonna give you the point for that, okay? So just bomb question 1. So either way, now, just for practice, where do you see the base peak? 29, what does it represent? That's where you can find it, but what does it represent? Most common fragment. So am I looking at a carbocation or a radical? Carbocation, beautiful. Do I have an N+2 peak? No, so that means that I don't have which atoms? More specifically, there are 4.
BHN. Carbon.
If I don't have an N+2 peak, I don't have bromine, chlorine, oxygen, or sulfur. Okay? That's all it means. No. Yeah, N+2, not N+1. If it was N+1, then you were correct. Yes. Don't worry, you're good. Okay. Ready for the next one? This one is gonna be more conceptual.
The bottom part, that 44.
That's your N+1 peak,
Yeah.
and that represents the isotopes of carbon, hydrogen, and nitrogen. What's the major contributor for the N+1 peak?
Carbon.
Beautiful. Okay, ready for the next one? Conceptual question. Should be simple. Do we think it's B or D? C? D. Because they're asking you, first of all, we're talking about mass spec, and we're being mentioned with bromines and chlorines. Those guys are only shown in your N+2 peak. What was the ratio that shows you that a bromine is present? 1:1. So what's 1:1? What am I comparing it to? N+2. Yes, you're correct. And then what about the chlorine? What's the ratio? Okay, so far, questions on mass spec. We're just reviewing general knowledge. Question in the back. For bromine. So for bromines, that's whenever we compare the molecular ion peak and the N+2 peak. If they're about the same height, bromine is present. If the N+2 peak is about a third of the N+ peak, that means that chlorine is present. Then if it's really tiny, it can be sulfur or oxygen. Okay. The next one, we did it already, so just shout out the answer. There you go. We're good. Okay. Let's look at the next one, guys. Okay. This time you're given the spectrum, and you're given only 3 answer choices.
No.
Is there a letter D or no?
No,
No?
it's only 3 answer choices.
So it's. Be a B.
That was fast. Why do we think it's B?
Wait, A, B, C. Oh. I was looking.
Okay, we were looking at different things. First of all, do we get C? Okay, I have B and C.
Oh, it's
I have A and
odd,
B,
it's odd,
it's
so
an
it
odd
has, it has the odd number for the
So it has to be an
molecular
odd
weight,
number of nitrogen.
so yeah.
Okay, so there's a few things that you guys
Wait,
noticed.
N+1, that means there's an oxygen too, right?
I think
And
it was-
+1?
No, we're just looking at the molecular weight and then looking for the odd number of, it's
Yeah.
just the molecular weight.
Okay, so we just refreshed on the concepts behind the peaks. Now we have to apply them because we're given the spectrum. Yes. We think it's B. Okay, so mostly B, 1C. Okay. Okay, let's start reading off the spectrum. What's the base peak? Where do you find it right now? Okay, this guy, it's my base peak. Where's my parent peak? 87. Okay. What information could I get just by looking at those 2 peaks? What do you say? From the N+ peak. What information can I get from the N+ peak? What does it represent? Specifically, because we see that we have an odd number, that means that I have an odd number of nitrogens. Exactly. So I can automatically start discarding option C because that's the one that has an even number, 2 nitrogens in there. Okay, now I'm between A and B, 50-50 shots. So next thing that I'm gonna look for is an N+1 and N+2 peak. Do I have an N+1 peak? Yes. Do I have an N+2 peak? No. So what does that mean?
No oxygen.
No oxygen present. So that means that the option was, the answer choice was B. Yes.
You mentioned something about what can you find comparing the base peak and fourth peak, isn't it something like? There's.
Not comparing, just by looking at those two peaks. What kind of information could you gather? By having that information, basically. It was not to compare them. But yeah, don't worry, you're good.
Will you also look at the molecular, is that the molecular weight up there? Or that's the MZ?
That is the intensity.
Oh,
That's something different. Intensity, it's on your y-axis. Question. Yes, so in this case, first of all, first thing that you're gonna do whenever you're presented with a spectrum is identify your 4 peaks. If the M+2 peak is not present, that just automatically means that there's no bromine, chlorine, sulfur, or oxygen, okay? Now, you could also do the math, just add up which one just equals to 87. But that's gonna take you a little bit longer, so, yeah. Okay. Questions so far on that? We're good? Make sense? Questions? No oxygen, no sulfur, no bromine, and no chlorine. Those are the only 4 atoms that are represented in your M+2 peak. Okay. Ready for the next one? We only have 2 more. And the last 2 are slightly more complicated.
glass.
Yeah, we just.
Glass.
Okay, what's the answer?
I don't.
Yes, it would, but who can explain it?
Oh.
You have it, so you have the M+2, so you know that there's gonna be oxygen, so you can get rid of C, just based off of that.
So yeah, again, you might be given data in either the spectrum form or just listed this way, and that applies for both mass spec and HNMR. Now, we know that we're given the M+ peak, that's your molecular ion peak. Next to is just M+1 and M+2 automatically, because we have M+2, we know that we need some sort of heteroatom in there. So like you said, C and D, they are not making so much sense in there. Now, after that, how do we get a specific answer? You just add up the molecular weight, exactly. So remember, that's gonna be with the periodic table, and remember to bring your calculators. So yeah, and just if anyone wants this for reference, this one's 86, this one's 84, and this one's 86. Okay. So again, very simple question. It just looks a little odd. Okay, ready for the last one? No, okay, it's okay. Okay, just let me know when you guys are ready for the last one. Okay, it seems like we're good. I just see the IPUS right on my face. Okay. Mm-hmm. For this one, you do need to look at the periodic table. But just in case if you can't see it, chlorine, it's about 35, carbon 12, hydrogen 1. So you have all of the data that you might need to use. Again, as far as the weight, chlorine 35, carbon 12, and hydrogen is just 1. Do we have any answers so far? We have an answer? We think it's B maybe? Okay, have one vote for B. Any other answers? Did we all get B?
The base.
E? Okay, I have B and E.
The base peak is the most common to letting, right? Yeah.
It doesn't always-
Think about it conceptually. Go back to your basics.
I don't have to get that.
We think it's B as well?
B has the closest. B is B.
Okay. Ready to work through the problem? Or do you have any other guesses? Okay, so in this case, we are given the base peak. Wait, sorry. They're asking us to predict the base peak. Okay. We know that in the spectrum, we can find it as the one with the highest intensity, but what did it represent? Most common fragment, which means that you're looking for the most stable fragment. Specifically, most stable fragment. Okay. So now, remember that whenever you cut up a molecule, you're gonna end up with a carbocation fragment and a radical fragment, but we're focusing on the carbocation portion. Okay? Okay, that's the concepts that I need to remember for this question. Now, I'm giving 2-chloro-2-methylpropane. Hopefully, we do know how to draw the molecule. Propane is just a 3-carbon chain, so let's just start drawing them out. And carbon 2, we have chlorine, and we have a little methyl group in there. Okay, that's my molecule. That's the entire whole molecule. But again, base peak, it's the most stable fragment. For the stability of a carbocation, what's the most stable type of carbocation that I could have? Tertiary, exactly. Okay, so remember, the more substituted you are, the better it is. Okay, now, again, fragmentation, I have to cut up a part of the molecule. So I have a potential tertiary position right here. So if I fragment it, just by taking out the chlorine, chlorine is gonna be my radical fragment. Then I'm left with my tertiary carbocation. I know that's my most stable fragment, just because of the concepts that we just talked about. So what's the weight overall of this guy? It's about 57. We have 4 carbons, we have 9. We just multiply by their weight and it should give you 57. So what was the answer? It was D. Okay. Carbon weighs about 12, hydrogen about 1. And then I just gave you the data of chlorine just to distract you. Yes.
Do you think it's gonna be for its test and memorize those like patterns?
I mean, either way, the periodic table is given to you. So I wouldn't add anything extra to just memorize it. You're given the data, so you're good. Yeah, if you want to, then yes, carbon, hydrogen, and oxygen tend to be the most commonly used. Chlorine, usually we don't do that much math with it, but yeah, carbon, hydrogen, oxygen. If you know them on the spot, it might save you some time. But that was the end of the review for chapter 9, before you start packing up. Because I already saw some of you just getting your stuff, but yes.
The base peak, it's showing the pattern for, I guess, the carbocation, the most stable one, right? What if you had 2 carbocations? Then it would just be, or would we?
You're not gonna get to carbocations. So the fragmentation pattern is that you always need to create some sort of radical and some sort of carbocation. Why? Because in the mass spectrometer, once we put the molecule, we're basically just taking away one of those electrons. And that's why we end up with a radical. That's why it's only one electron. It's not a lone pair, let's say. Okay. Now, I saw that your professor mentioned what's gonna be on your exam for chapter 11. It's all that we already covered. So do we have any questions on that? It's basically just naming, acidity, boiling point, addition reactions, yes. Okay. The one with the hybridization that we were talking about? Yeah. Okay, do you have any questions? Question over there? Yes. Yes, and
There
one
was a
request?
question asking which was the acid, gave the bases, would the base be closer towards the
What do you mean he gave you the basis?
Are you talking about the one that
Show me the
has
problem.
iodine, chlor-
That's based on I can't say the word, polarizability?
No,
Pol-
it's not based on
polar-
which one was more.
polar something, polar something. Yeah, but either way, let's go back to the handout in this case. Okay, before we start talking about acidity, let's just quickly remind ourselves of the boiling point trend. As long as you're able to remember the trend, you should be good for any boiling point questions. So the higher the boiling point, that means that the molecule has the stronger intermolecular forces, which remember, it goes, hydrogen bonding goes first, then dipole, and last one, it's the one that's present in every single molecule, London dispersion forces. Now, if every molecule has the same forces, then you move on to the next factor, which is branching. The less branching, the higher the boiling point. And then last aspect is they have the same exact branching. You're gonna look at the molecular weight. The higher the molecular weight, the higher the boiling point, okay? It's just a trend that you guys have to memorize, and you probably learned that back in Orgo 1 at the very beginning of the semester, okay? But let's go back to our acidity question in here. No, I remember the question that we were doing in tutoring, so let me just draw it out in here. Okay. Okay, might be slightly different, but. OH, CN. Okay, I don't remember every single answer choice, but those are the main ones to talk about this. Okay. Just had an, so a phenol, just a phenol.
Because that was like the one that I thought was correct. It was CO2H. And then bottom which all, yeah, but both of them, they all had CN. Yeah, they all had cyanide. That one was a good one. It didn't have cyanide. It had it, meta. No, just a methyl. No, just a methyl.
Just a method. Okay. Now, you might have seen this question if you took the practice exam, which hopefully everyone in this room already did multiple times. But either way, this case, either you were asked for the most acidic molecule, least acidic, or maybe to rank them. But just for practice, let's start ranking them from most to least acidic. So for this case, you're not given pKa value, so that means that we're going to be relying on REO. Okay, now for REO, let's start with letter by letter. So first one is atom. Do they all have the same atom? No? Okay, remember that for the atom one, we're only looking at the hydrogen that's at the most acidic hydrogen and what's nearby it. So in this case, remember alcohols, we consider them acids. So we're looking at these hydrogens in here. They are all connected to an oxygen, and then CO2H, what's that? What kind of functional group is that? Carboxylic acid. So it's gonna look like this, but same process. That hydrogen is connected to an oxygen, so they all have the same exact atom. Since they all have the same exact one, I'm gonna move on to the next portion, which is resonance. Okay, so far, does that make sense? How to use REO so far? Okay, no. Next one is resonance. What was the trend for resonance and acidity?
The more resonance, the more stable.
The more resonance, the more stable, the more acidic. So just by looking at those four molecules, which one looks like it's gonna do the most resonance? The one with the carboxylic acid, yes, exactly. So remember, some rules for resonance. First of all, it's not a reaction, so you're not gonna be breaking any single bonds, okay? You're not moving any other connections, you're just moving around your electrons. To do that, you can only move towards sp2 or sp atoms. If you have anything that's sp3, you have to move away from them, because if you don't do so, you're gonna break the octet. So in this case, we can see that the one that can do the most resonance is the one with the carboxylic acid. That's usually whenever you have any answer choices that have a carboxylic acid, that tends to be the most acidic one of all, okay? So just a little PSA for that one. Now, which one is the least acidic? Which one can do the least amount of resonance? Why the third one? Because it has a little CH2 group. So remember, we were talking about the rules of resonance. This guy, it's sp3. So as much as I want to stabilize my negative charge here, once that hydrogen goes away, I'm not going to be able to do so. It's just going to stay static in that oxygen because this carbon is blocking my way from getting into my benzene ring. Okay. So that's why this guy is going to be the least acidic. And then between the first and the second one, which one is more acidic than the other one? The second one, because CN, it has a triple bond as compared to a methyl group that is just pure single bonds. So this guy is going to be 2 and 3. Yes, yes. But as long as you look at each of the factors individually in ARIA, in that order, you should be able to get the answer right away. Okay. Questions on ARIA? Did that make sense? I saw you first. Resonance again. So remember, to be more acidic, you need more resonance. Why? Because after we deprotonate our acid, we're left with a negative charge in that oxygen. So say it again. So resonance is something that's going to happen just naturally in the molecules. It's just going to be the constant movement of electrons. Okay, so that always happens whenever you have any double bonds, lone pairs, triple bonds, things like that. Okay, other questions? Are we good? Last one. You got it. So yes, that was it. Hopefully you guys are going to be ready for Friday. But if you have any last minute questions, just send me an email. We are still going to have SI on Friday right before the exam, but I'm not going to be going over any handouts. It's just going to be like a tutoring session. So if you have any last minute questions, just pop right in.